Hey, again. All right. This video is on exponents. We have not done exponents yet, but we will this week, and I wanted to get a video out for those who will not be here or want to maybe feel prepared, or hey, let's face it, the week back is going to be crazy and I'll have this done before then. Exponents, you may or may not have been introduced to in the basic concept of expanded and standard form, but we're going to do some operations with them too. Okay, it's not that bad, I'll promise. This is a basic exponent, 7 to the third. If I asked you to expand this, it would be 7 times 7 times 7. If I asked you to solve it, it would be in your calculator, 7 times 7 times 7, which I don't care to do right now. This is expanded. If I asked you to condense it, it would be 1, 2, 3, 4, 5 11s. 11 to the fifth. So what is an exponent actually asking of you? That little number is telling you to multiply the base 3 times. It is not 7 times 3. It is not 11 times 5. It is 11 5 times. It is 7 3 times. Okay? Expect a horse to come in. So, knowing that, we're going to do some practice on basic, expanding and condensing these, plugging them into the calculator, getting used to wiring our brains to see this the right way. Not bad. After that, okay, we're going to do some operations with them. And I've written some down so I can not forget them. If we were asked to add these, real simple. You could do this expanded. 5 and 5. And how many 5s is this? 7 of them. Why do I do examples with such big numbers? I don't know. Okay. Can you combine those? No. If I asked you to solve it, could you do 5 to the 9th? Well, let's find out. I'm going to go grab the calculator and prove it to you, because who wants to do that many multiplications? What is 5 times 5? 5 times 5 is 25. 5 times 5 times 5 times 5 times 5. 5 to the 7th is, yikes, okay, 78,125. If I add those together, it's 78,150. What is 5 to the 9th? So much bigger. Why? Because of this right here. Okay? This is adding 2 numbers together, not multiplying them. 5 to the 9th is all multiplying. So a simple rule for you is if the exponent is different, you can't add them. I don't care what's going on in the base. I don't care. Now, could you expand it out and solve it? Yeah, like we did, right? But if you're trying to simplify things in an equation, and the base is the same, but the exponents are different, and you're trying to add them, there's not a lot you can do besides solve it, okay? Let's talk about multiplying them now. I should have done that here. Okay? So now I say 5 squared, 2 and squared are the same thing, cubed and tripled, cubed and to the third are the same thing. Okay? Little fun fact. Miss Vaughn, there's a lot of stuff you say, and then you're like, you know what? Here's the thing. Math is learning a language. I've said this. I'll say it again. It's good to see. I've seen some other people start talking about that. Have you ever been in Spanish class, and they're like, yeah, you can say that, but that's the more formal way. We just say this. That's the same thing with math. To the second, we just say squared. How would you have known that? Well, I just told you. Okay, so try not to get frustrated when you're given little tips and tricks of the trade here and there. Just collect them on your tool belt, use them or lose them, and then use them next time you hear them. It is a growing process. 5 squared times 5 to the 7th. Is this different? Well, like I said, 5 to the 2nd times 5 to the 7th is a giant number. 5 squared times 5 to the 7th. It is, 1,953,125. Okay, what if I don't want to write that? That's the value of exponents, people. Exponents and scientific notation, which is what you'll get into in another unit, are a really handy way of condensing really big numbers so that we don't have to write them out giant. And this is helpful. 5 squared times 5 to the 7th. 5 squared, 5 to the 7th times is, oh look, 2, 3, 4, 5, 6, 7, 8, 9. The same as 5 to the 9th. You can do two things. If I've asked you to condense this, you can either write it out like this and then come to the conclusion that it's 5 to the 9th, or you can add these exponents to get 5 to the 9th. So if I said what is 5 to the 31st times 5 to the 6th, you could do 31 plus 6, 5 to the 37th. Ma'am. Okay? Let's talk about division then. Let's talk about division with exponents, okay? Some of these are on the worksheet that we're doing in class, so if you're watching this, you'll have a few answers, which is nice. 3 to the 6th divided by 3 to the 2nd. That's a fraction, Miss Vaughn. Yeah, we talked about this. Division and fractions, kind of the same thing. Part out of a whole. Oh, look, division. Division is taking a part out of a whole, right? How many times does 3 go into 27? A part out of a whole. So a fraction is a part out of a whole. They're the same thing. Nobody told me that when I was your age. Handy. All right, what is this? Well, 3 to the 6th is how many 3s? 6. 1, 2, 3, 4, 5, 6. Over 3 times 3, right? You could do this in your calculator, okay, and I'm going to prove it to you. So you're going to do 3 to the 6th divided by, here, let me write this out nice and pretty for you. 3 to the 6th divided by 3 to the 2nd. That's 81 right there. That's 81. I'm going to prove to you, and yeah, you could do that. But if I asked you just to give me the simplified version, what are you going to write? Well, let me show you. 3 times 3 times, let's do the top. Let's break this down, okay? 3 times 3 times 3 times 3, 3 to the 6th is 729. 3 times 3 is 9, okay? So 729 divided by 9 is 81. Cool, we like that. These are the same thing. I don't want to do all this. Is there a simpler way? Yes! Okay, question. What is 2 divided by 2? 1. Arguably, what is 512 divided by 512? 1. What is x divided by x? What? It's a letter. Shh. 1. Anything divided by itself is 1. Pi divided by pi is 1. Negative I divided by negative I is 1. Don't ask. Okay? So, by that concept, I can cancel out twinsies here. 3 divided by 3 is 1. 3 divided by 3 is 1. And now I have 3 times 3 times 3 times 3. What is 3 to the 4th? Oh, it's 81. I love this. When I did the multiplication, I told you, you can add the exponents together. When you divide, oh look, 6 minus 2 is, it's 4. When you divide exponents, you can subtract them. And this is why, okay? If you need to do this part to get to your answer, do it. Do it. Math people love doodles, okay? Do it. All right, let's talk about one more that you may see over the next week or so, okay? Actually, we have 2 more examples, which is crazy. I feel like I'm in class. This video might take forever, okay? What if you did, an exponent raised to an exponent? Same thing, we're going to work through it logically. 4 to the third is 4 times 4 times 4. Okay. That is one thing. And I'm asking that this thing be squared. Well, what is 5 squared? It's 5 times 5, right? So it doesn't matter what the thing is that I'm refusing to look at right now because I don't want to get overwhelmed. It doesn't matter what the thing is that's the base. If you're squaring it, or to the second, it times itself, right? So let's take this times itself. Okay, I squared it because this is this thing times itself, which is really 4 times 4 times 4 times 4 times 4 times 4. It is really 4 to the 6th. Now you can plug this in. I think you're bored with that now, so I'm not going to do it. But 4 to the third squared. If you are raising an exponent to another exponent, you are going to multiply these guys together to get 4 to the 6th. If you needed to do this, you could. Slow down, fight the overwhelm, think logically about it, okay? Math is not secretive. It's not sneaky. It's not trying to confuse you. And in fact, when you realize, especially you neurospicy folks, from one neurospicy ADHD to another, math is logical. Math makes sense. It follows rules. It has expectations. It is order in a world of chaos. There's no wonder I like math, okay? I don't understand people a whole lot, but I do understand numbers, okay? Onward. You're about to be upset because you're like, okay, I get this. And this is how the world is, right? Like finally you figure it out and then it's like, now let's combine simplifying an expression and exponents. Okay, we can do it. Shh, don't panic. Stop panicking. Oh, look, an X. I don't like that, but it's on the X. It's on the worksheet. Different slang, so to speak, right? Is it parentheses? Is it a dot? Is it an X for multiplication? I don't know. Depends on who wrote it. Woo! Okay. She's a mess. Now, could you put this whole thing in the calculator? Yeah, you could. That's not the point. I know a few of you who want to. You know who I'm talking about. That's not going to work when I give you giant numbers. There's this thing called overflow error on these lovely calculators. And if the numbers get too big, well, one, it's going to say overflow error, or it's going to say it in scientific notation. That's not the answer I will accept. So let's focus. This is an order of operations problem. Remember, with order of operations, we are going to do PEMDAS. We're going to work our parentheses first. I'm going to rewrite everything I'm not touching. 5 to the third, not doing it. Look, parentheses. Inside the parentheses is a 2 plus 1, 3. I'm going to leave that squared there because I'm not doing it yet. I want to write all this out. Tough luck. Strengthen your hand muscles. Let's get to writing. Now, okay, we did our parentheses. They say do exponents first. Well, that's a lot of exponents. Let's see if we can simplify anything. Okay? Well, okay. Here's what I'm saying over here. You want to do your exponents first. That's right. Let's do it for sake of doing it. Remember with exponents, and you'll see, I'll show you what I was talking about. Okay? You can't combine anything that's added. Okay? Even if they're the same base. So the 5 to the third is coming down because we can't do anything with her. But we do have multiplication here, and they have the same base. Remember I said when you're multiplying, same base, exponents are added. So 3 squared is 3 times 3 times another 3 times 3. That's 3 times 3 times 3 times 3, 3 to the 4th. Okay, I'm going to bring this guy down because I didn't do anything with it yet. I want to see this work on that worksheet. Why? I can just plug it in a calculator. Because I want you to develop your problem-solving skills. I want your brain to do exercises. That's why I'm here. Can we combine these two? They have the same base. No, you can't do that. It's messy. At this point, though, we can expand this out if we want. Just to visualize it. You don't have to, though. At this point, there's not a whole lot you can do with it. Okay? So I want you to do 5 to the third, which is 5 times 5, which is 25 times 5, 125. How'd you do that so fast? When you work with numbers, the more you work with them, you're going to start just by accident memorizing certain things. Okay? My daughter loves 6 times 6 is 36. I don't know why, but I remember 5 to the third is 125. Don't ask me how the brain works. Okay? 3 to the fourth. 3 times 3 is 9 times 3 is it 81? Oh, see? 81. Plus 81 minus 9. Now up here, we're going to see, I'm getting excited. This is the point where we can add them all together. And we get 197. This was honestly not that bad, guys. You only had to use your rules of exponents once, and that was to combine these. Could you have done it without that? Yeah, you could have. I still want to see these things expanded out to their number, to their values, and then add them. If you show me work and you do it in a different step order, but still follow PIMDAS, but let's say you group things in a way that's different than me, and you're still following the rules and you still get to the answer that is correct, and I see that, then you did it right. You just did it you took a different route than I did, but we still get to the same school. Even if we left from the same house, we took different paths, as long as we both still followed the rules of traffic, we'd get there, okay? Maybe one of us took more steps. It doesn't matter. Exponents, I think you will realize you like. Maybe not. But that's where we're headed over the next week. Hope that helps.